Hello everyone, my name is Kosti and I'm from Team 23161, Cyberlis76. Today I will be giving you an introduction to CAD along with some practical tips. First of all, the program that I recommend most for beginners is Onshape. Onshape is a cloud-based CAD platform used to create 3D models, assemblies, and engineering drawings. It's very useful because you can run it in your browser, it automatically tracks changes, branches, and history, and you can work in the same document with multiple teammates. In Onshape, your work is divided mainly into part studios and assemblies, and each has a specific purpose. A part studio is where you create parts. You can sketch, extrude, and use features to build 3D geometry. You can model multiple parts in one part studio, which is useful for making parts that fit together perfectly. All parts share the same workspace and reference geometry, making it easy to keep things aligned. The most important feature of a part studio is sketch mode. It is the workspace where you create 2D drawings that serve as the foundation for almost every 3D feature. You start off by selecting a plane or a flat face. In sketch mode, you can draw 2D geometry such as lines, circles, polygons, splines, and etc. You can add constraints to control your geometry. Common constraints include horizontal, vertical, parallel, perpendicular, tangent, and coincident. You can also dimension your sketches to give numerical values to geometry, such as length, diameter, distance, and lines. Another important feature in sketch mode is construction geometry. Construction geometry is there to help define a sketch, but is ignored when creating a feature. Any sketch entities can become construction geometry, and it can be toggled on or off in the toolbar. Now, let's talk about assemblies. In Onshape, an assembly is where individual parts come together to form a functional mechanism. Unlike traditional CAD systems, Onshape assemblies are built on a constraint-driven system called mates, which define how parts move, rotate, and interact. When inserting components, Onshape allows the use of Part Studio entities, assembly substructures, or external CAD imports. For complex builds, such as FTC robots, I highly recommend structuring your assemblies hierarchically, and by that I mean using sub-assemblies which isolate functional modules, and using instance patterns to reduce definition redundancy. This organizational model reduces computational load, improves rebuild performance, and enables parallel team workflows. Onshape controls component motion through a constraint system based on mate connectors. A mate connector defines a complete local coordinate system, including origin and three orthogonal axes. Mates operate by constraining two mate connectors. Common mate types and their mechanical degrees of freedom definitions include fasten mate, constrains all 6 degrees of freedom, revolute mate, constrains 5 and permits rotation about a defined axis. Slider mate constrains 5 and permits linear translation. Cylindrical mate constrains 4, permits rotation and translation along one axis. Planar mate constrains 3 degrees of freedom and permits 2 translation plus 1 rotation on a plane. Ball mate, which constrains 3 translational degrees of freedom and allows 3 rotational degrees of freedom. Now it's time for some tips and tricks. My first tip is going to be about constraints. To improve accuracy and maintainability, rely heavily on constraints rather than manually adjusting geometry. Use fix sparingly and focus on fully constraining geometry logically instead. Take advantage of powerful constraints such as use to reference existing edges, pierce for lofting paths, and equal for symmetric design. Constrained sketches rebuild faster and reduce unexpected feature failures. My second tip is going to be about configurations. Configurations in Onshape allow you to manage multiple variations of a product within a single document using design-driven choices. This streamlines how components are created, organized, and selected throughout the design process. Instead of managing long and complex tables of predefined combinations, you define simple input criteria such as lists, checkboxes, or variable fields that guide how variations are generated. Any feature or parameter can be configured, including dimensions, suppression states, formulas, and selectable inputs. Onshape updates the model instantly based on the choices, eliminating the need to manually create and store every configuration. You can also change sketches, faces, or feature inputs dynamically, allowing highly flexible design definitions without extra complexity. With only a small number of user inputs, you can efficiently control and access hundreds of potential product variations, all within a single, streamlined configuration interface. In this example, I have made a configurable standoff that uses input parameters to change the shape, the length, and the width of the standoff, depending on the case that I need to use it. My third and final tip is about using Replicate in assembly. Replicate lets you create copies of parts or sub-assemblies in an assembly without manually mating each one. Unlike simple copy-paste, Replicate preserves make connectors, offsets, and assembly references. This ensures that the replicated parts maintain the intended mechanical relationships, perfect for patterns of bolts, pins, rollers, or repeated modules in your robot.